What is up, amigos? Today we're looking at the aerodynamics of a dustbuster. And dustbusters are just one of those things that seem to be magical, like no one really knows how they work. So we have the cut planes downstream, and we can see that the wake is fairly big. It's very unstable. You can see it even in like this first plane, it wobbles around a lot, but it's quite symmetrical still. So the second plane, you can see both of these lobes that roll up in the bottom half, and then they start to break down asymmetrically. Now we have these exact same planes, but we can now see like the subdrag, so the drag breakdown in the actual wake, where the very yellow and green parts mean high drag, the purple parts mean fairly low drag. And then when you can't see anything, that means that there's no drag, it's still free stream effectively. And those lobes are producing quite a lot of drag. However, they start to die out quite quickly, and it's the top part that seems to really propagate downstream, and that's where the drag seems to be concentrated as we go downstream. This is a Y plane going straight through halfway in the dustbuster, and it shows the velocity magnitude, the deficit effectively. And interestingly, with the other cross planes, we saw that there was quite a lot of unsteadiness in those planes, but in this plane, there is a little bit of unsteadiness. So for the bottom half, there's like a little bit of flow that just keeps popping back up, and it recirculates around a little bit, but it's not nearly as unsteady as what those other planes would suggest. So that indicates that the unsteadiness is coming from the Z-axis, which we'll see in a little bit. So this is the exact same plane, but now showing the subdrag. And pretty much the entire thing is just one lump of drag producing material. Even the handle, even though it is quite thin compared to the rest of the dustbuster, it is still producing a lot of drag, and that's because you have two elements effectively in series. So the wake from one is hitting the other one, and that just exacerbates this wake and the drag that's being produced. If you made this a like one handle piece and there wasn't this middle part that's being cut out, that would make it probably a little bit more streamlined, which means that the drag would probably reduce. So now this Y plane is right on the edge of the dustbuster, and it's pretty cool because even though you have a small wake just near the dustbuster, as you go further on, like the wake gets bigger, and that's because if you remember from the first X planes that we saw, those cross planes, when we went downstream, there was like this three-dimensionalness that just broke down and it started to expand a little bit in that direction. That's what's happening here. We can see that. Now I can tell you that the drag of this thing is pretty bad. It's a 0.56, the drag coefficient. So it could be better from that point of view. But the lift coefficient is actually pretty decent. It's got a negative lift coefficient of 0.091, which means it's producing downforce, which makes sense because this wake is at an angle. And that indicates that when you're like dust busting around, the dustbuster is actually sort of getting sucked to the floor. So obviously whoever designed Dustbusters, they're an aerodynamicist, and they designed it so that it would, facilitate a more user-friendly dust busting experience. Now we have a Z-plane right at the bottom of the dustbuster, and I should note that this dustbuster, it's being placed at an angle so that the nozzle isn't completely flush with the ground. It's off a little bit so that, if you put the nozzle flush to the ground, then it starts to just suck to the ground, and it's like really annoying trying to rip it away. So any person who knows how to use a dustbuster knows you have to put it at an angle to like zoom it around a little bit better. So that's what I've done here. And the wake is quite small here, even though there is a little bit of the dustbuster visible. Now, interestingly, this plane is going halfway through the dustbuster in the Z-axis, and I would have thought that there would be more of a like obvious von Karman streak coming off of this, but there is some unsteadiness, but it seems to be quite well behaved still even now. Like the two blue and purple lobes that you see, they don't really fluctuate too much with time. They just sort of stay the same kind of length. So I'm not really sure why a von Karman streak isn't forming properly over this thing. It's quite interesting. This is the same plane, but it shows the drag now, the subdrag. And even though that von Karman streak didn't really form properly, we can still see there is quite a lot of drag from this wake. This Y plane is a little bit higher now. It's sort of like where the vents are in the dustbuster, if you know what I mean. And this wake now is showing a bit more of the von Karman streak that I expect to see. You see this periodic shedding of the flow, and it is fluctuating up and down a little bit more than what the other plane was showing. And this makes sense because perhaps we are now at a thicker part of the dustbuster, and we're further away from the edges of the dustbuster, like the handle or the tip, which means that this is more two-dimensional flow than the other sections, which were more three-dimensional because you have the flow from the tip and the handles, which corrupt that area. So this plane, again, it's the same one, but with the drag, the subdrag being shown. And I can pretty much tell now this is where most of the drag is coming from. You can see like there's a lot of yellow around in this plane. So this is where a lot of the drag must be being produced. So if you made this a bit more streamlined in this cross-sectional area, you could probably reduce the drag of the dustbuster considerably. So now this plane is going through the handle section. And interestingly, you actually still get quite a crisp von Kamstreit occurring, even though you have, as I mentioned, two parts to the handle, the upstream part and the downstream part. Often you would expect the upstream part, the wake from that, to hit the downstream part, and the von Kamstreit that occurs from each one sort of gets mixed up and cancelled out a little bit. But here we do get a von Kamstreit forming quite crisply, and it's probably because the upstream handle is significantly bigger than the downstream part of the handle. Now we have the Z-plane at the very top of the handle, and we have the sub-drag being plotted, and it's incredible how much drag there still is in this region, even though the handle that is coming from, like it slices through, is so small. But if you remember from the other planes, the flow goes up because this is producing downforce. It's sucking to the ground kind of thing, almost. So the flow that we see here, this drag, is actually coming from the rest of the dustbuster that comes up. So it can be deceptive. If we didn't see those other planes, we might get confused here. So that's it in the simulation. Make sure to like and subscribe. And if you want to get better at CFD like this yourself, or learn about the theory, for example, how dustbusters work, check out our courses in the link description. And I'll see you next simulation. Peace out, amigos.